All right, so we call a function even if f of minus x is the same as f of x, and we're going to call f odd, not if it's unusual, but if f of minus x is minus f of x. And I'll explain in just a minute what that means in a little more detail, but I want to go ahead and say f is even if and only if there is symmetry about the y-axis, and f is odd if and only if there is symmetry about the origin. Okay, so what do I mean by these things? Well, let's actually focus less on the algebra for now and more on the symmetry, and then we'll come back to this part of it, okay? So let's just look at some pictures. So if you look at, I don't know, let's say that, whoa, that's a bad line there. If you look at the graph of x squared, let's say that it looks like this, because it does. You can see there's symmetry about the y-axis. Now, the way that I drew it, there isn't symmetry. So let's try again. Something like, I don't know, it's kind of hard to draw this on this iPad. Something like that. So in theory, this is supposed to be symmetric. So if you spin this graph around the y-axis, then you would end up with the same graph over there. So this is f of x equals x squared. And simply by the symmetry of its graph, you know that the function is even. And on a similar note, let's do another example. I don't know, let's do, let's do x cubed. And you can see that it looks something like this. And so here you can see there's symmetry over the origin. The idea is take what's ever here and flip it down. And when you do that, when you flip it sort of down and around, if you will, then you would end up down here. So this function is f of x equals x cubed. This is an odd function, and it has symmetry over the origin. So whatever's here, you're sort of flipping it down into the opposite quadrant. Whatever's here, you'd flip over there, so on and so forth. Okay. So you can see that these symmetries visually pretty easily. What I'm interested in now is understanding them algebraically. So let's go back and figure out what this means. So here's what you do. If you want to check a function to see whether it's even or odd, all you do is you take your function. Let's say that our function is f of x equals x cubed plus x. And you always start by plugging negative x into your function. You want to see what it does when you plug in negative x. So for us, when I plug in negative x, I would get negative x all cubed plus minus x. And so I say, well, okay, so this is the same thing as negative x cubed minus x, because the negative comes out of the cubed, and these are positive minus makes a negative. And now at this point, you can factor that negative out, and you're left with negative x cubed plus x. And lo and behold, there's your original function f. This is minus f of x. So you've just shown me step by step that f of negative x is always negative f of x. And so that's a proof that in this case, f is odd. Let's see an example of a function that is actually even, and then we'll see an example of a function that's neither. So here's f of x equals, I don't know, let's say x to the fourth plus 2, okay? So I'm going to look at f of minus x, and I'm going to get minus x to the fourth plus 2, but the fourth power kills the negative. This is just x to the fourth plus 2, which is just our original function. And so I've shown you that f of minus x is f of x. And we can say thus f is even. And then one more example. Let's just say f of x equals, I don't know, x cubed plus x squared. I look at f of minus x and I get what? Negative x cubed plus minus x squared. So this is negative x cubed plus x squared. And now you realize this is not f of x, right? This is not, this is not your original function. We'll try factoring out a negative, and I realize what's left is not my original function. And so this function is neither. F is neither even nor odd. And so the point is, I'm not going to graph this function, but I know from the algebra that its graph is going to have symmetry over the y-axis. And in general, when you discover that a function is odd, then you know that it has symmetry over the origin as well. Okay, so that's just a quick rundown on even and odd functions. I'm going to end last video with just a quick review of function transformations. We really won't need too many of them for our purposes, not nearly all the ones that you learned back in college algebra. So I'll just show you a few and then we'll be done.